Ladies and gentlemen, in this Red Gaming Tech.com video, we're going to be analysing a GDC document from 2014 Europe GDC, which Ubisoft put out, which analyses the GPU and CPU performance of both the PlayStation 4 and Xbox One. Now, this is also an article where I've got a lot of links to the sources, as well as images of the GDC document, as well as some research notes and other bits and pieces if you so desire. Now, the primary purpose of this, and the reason I'm covering it for the most part, is actually because it's already being used against Microsoft on the whole parity issue. In other words, why are certain games running the same frame rate or the same resolution, and so on and so on. And basically this started off at NeoGAF, but it's been going around the internet quite a bit, and a couple of people have already asked me to cover this, so I am. I'm a bit late, but that's because I've been basically struck with the plague, but now I'm getting over it. I can actually mentally deal with this stuff. So anyway, as I said, do look at the document, but don't just skip down to the bottom where it's got like the PS4's GPU versus the Xbox One's GPU. I would recommend that you do take the time to read it all, because otherwise you're going to be missing quite a lot of the context of this document, which is really important. Anyway, so this document, as I said, was from GDC Europe 2014 and was written by a chap known as Alexis, hopefully I pronounced that correctly, and he's a lead programmer over at Ubisoft. And so what we should begin with is they're running cloth simulation. This whole thing really starts out as cloth simulation. It's primarily focused on compute and cloth simulation. So they're basically running dancers, which obviously have swaying dresses and stuff, and they are calculating the number of dancers you can run in a 5ms CPU time on Xbox 360, PS3, PS4 and X1. So what they found was the number of dancers on the Xbox 360, this is purely using the CPU, as I said 5ms, was 34, by the way, just to reiterate, all of this is in the article, and so I'm going to go over this quite quickly. I'm not going to keep reading it, so that it's easy for you guys. But anyway, so the 360 puts out 34 dancers, the PS3 puts out 105. We'll get into the discrepancy of that in just a second. The PS4 98 and the Xbox One 113. Now, tackling the PS4 and Xbox One first, the reason behind that is quite simple. The PS4's CPU runs slightly slower than the Xbox One, so it runs at 1600 MHz versus the Xbox One's 1750. Simple. With the PS3, the reason of the discrepancy is because it's using SPUs, the synergistic processing units. In fact, in a slide that I didn't include because it's just pointless, because all it says is SPUs rock, Ubisoft are actually pointing out just how important these vector processors were for the cell. There are links on how all of this works in the document, as I said. But anyway, moving on. Then they go, and this one's important, I just want to be really clear, the relative performance of the CPU and the GPU between both machines. So in other words, the PlayStation 4's CPU versus its GPU. So the Xbox One and the PS4 are not facing each other in this particular situation. The reason I want to highlight this is because we're basically talking about the importance of compute, not necessarily the machines against one another at this particular moment. So in terms of peak power, so in other words, best case scenarios, this is like if everything's going well, you're not having bandwidth issues, you're not running dozens of other things which are trying to happen at the same time. We're talking the best possible scenario. The Xbox One's CPU is about 15 times slower than its GPU, whereas the PlayStation 4's CPU is about 23 times slower than its GPU. So what gives us the numbers here? Well, there's a couple of reasons, and some people are probably understanding what they are already. The first one is raw clock speed of the PS4's CPU. In other words, it's slower. So because it's slower, it means that, well, the CPU has, it's just worse performing, right? The next is the PS4's GPU is faster. It's running at 1.840 flops compared to about 1.31, 1.32. So there's quite a lot of discrepancy there. So I've actually gone into the mathematics of how you can calculate this yourself in the article. I'm not going to go into it because, well, I'll have to tell you various numbers to multiply. It just makes it a lot easier to write as an article. But suffice to say, it's pretty simple, and it's something pretty cool as well you can do yourselves. So if you've been following along so far, the crux of the matter is this: the CPUs in both machines are relatively weak compared to their GPUs, and thus it becomes extremely important to start offloading work from the CPU to the GPU. It's the only logical choice you've got left. And therefore, the high shader count of both of the next generation consoles, well, that's basically made for single instruction multi-data nirvana. Quite simply put, there's loads of little processors inside the GPUs, and those processors, multiple of those can be assigned to a task, and they'll run that task until they complete it. Pretty simple stuff. Unfortunately, GPUs are pretty dumb. They have very poor logic following arguments, and they're not very good at interpreting code themselves. They've also got other weaknesses as well. And basically speaking, they're not great at branch prediction, and they're not good at basically figuring out what they need to do. And this is why they have a more complicated instruction chip usually paired with them. In other words, the CPU. As the CPU can understand a greater deal of control structure, and therefore it is the one that's actually responsible for to tell the GPU, hey, I need you to do this task, please, and I need these results, and I need you to copy them by this point, and so on and so on and so on. So in other words, you can think of the CPU as giving instructions to the GPU. To do this, it has to dispatch these instructions, and the problem is this can still take a lot of workload from the CPU. So what initially happened is they were having this situation where there was a massive bottleneck still caused by the CPU. They weren't gaining anything really. 100% CPU usage, 5% GPU usage. Sucks, awful, bad, it's not going to happen. So what they decided to do, Ubisoft, pretty smart, kind of natural, was they decided to have synchronization points inside the shader. They used a huge compute shader simulation for the entire cloth, whatever, the entire piece of material basically, and then they also reduced it to a single dispatch instead of 50 plus, and various other improvements as well. And all of these together meant that the GPU now was putting out 160% relative to the CPU, which is, well, a hell of a lot better. So if you've been following so far, what you're going to notice is that, okay, that makes logical sense, but what about the memory bandwidth? Well, memory bandwidth is still an issue, and as she said, quite simply put, and very bluntly, that a bottleneck right now is still the memory bandwidth. They were very explicit on this. In fact, they had a slide that points out that almost 2.5 times improvement in performance just from using compression alone. Now remember, the PlayStation 4 is using that GDDR5 RAM, so it's got 176 gigabytes of memory bandwidth and all of that, but unfortunately it's relative high memory bandwidth compared to the shader count. In other words, what I'm saying is that it's not excess memory bandwidth. It's roughly what you would expect the CPU and the GPU or the system itself to have, considering the raw performance of the GPU and the actual CPU. And by which I mean, if you were to look at an interview that I actually did with AMD themselves, they even stated that given the amount of memory bandwidth, or should I say, given a certain amount of compute units, this is roughly how much memory bandwidth they use. That's from AMD's own mouth. So basically what I'm saying, and if you can look at other cards they've got, quite simply put, the GPU is running, of the PlayStation 4, it's running roughly what you'd expect. So you still can't have sloppy code. So that's why data compression is so bloody important. Indeed, in the very brief section of the interview, I've linked it once again in this article, but he did ask regarding the whole resolution issue, that it's actually best to work backwards. What performance and resolution target do I want to hit? And then you build a core around the paper, around the mathematical models, which would yield the performance equivalent to hit that target. So for 512 CUs, he would suggest, for example, 32 texture units, 64 ROPs, and 128-bit bus. I'm sorry, I don't mean shader units. I meant to say 512 shader units, not compute units. Sorry, my mistake. So anyway, moving on. What about we've discussed optimizing the shader in terms of using compression. Now it's also important to understand that you need to start using local data storage. LDS, local data storage, is 64 KB of memory that's there for various purposes, but primarily the 64 KB of local data share is to facilitate information flow around the different data lines. So you've got an LDS for each of the CUs, effectively. And just to reiterate, that's 64 KB total. Now when we did an analysis way back from both Sucker Punch and a Naughty Dog, they discussed heavily the importance of syncing data. So that is making sure that the data is, well, smooth. So, for example, let's say you've got the data transferring from a cache to, let's say, the main system RAM, and then from that to like a different cache, blah blah blah. You have to make sure that there's no data out of sync. In other words, one that has an older copy, or the CPU is trying to access a piece of data that the GPU's accessing, so it gets like a write protect error, and so on and so on and so on. The data has to flow very smoothly, and a lot of this, according to Ubisoft, is that you have to do it manually. Now, that is slightly against the grain from what Sucker Punch have said, because they have said, well, you can write your own API, which does handle some of this, but to do this can be a bit tricky, and oftentimes it's just better and simpler to simply run it yourself. And what you can sometimes do is actually just issue a sync command to the actual GPU's buffer and say, hey, you know what, just stop what you're doing and just make sure everyone's on the same page here, please. But obviously that can tank performance. I have linked to that, both of those analysis in the article, so I don't want to go over loads and loads of stuff that I've already discussed previously for regular viewers. So moving on, you do need efficient code, of course, so that's working on 64 plus pieces of data at a time. That's to make it so that it's worth actually transferring to the GPU, and also so it makes full use out of the cache and all the other bits and pieces on the GPU, just simply because of the structure. In fact, they even said, you know what, it's not even worth running unless you know it really goes into that type of situation. It's just physically not worth transferring from the CPU. I've also included a excerpt of some code on the X11 on the PS4 where they're showing how you can run a compute shader on the buffer and so on. But that's getting a little bit more complicated, but I thought I'd just include it anyway. So anyway, well, where were we? He says as he looks through like a million lines of notes that he's got. Oh yes. So a lot of this stuff doesn't really come as much of a surprise if you're used, in terms of like the efficiency side of things, if you're used to the GCN architecture anyway. It's pretty simple. But it's actually quite interesting because if you were to notice, Ubisoft actually explicitly state that it's very hard to know what the compiler is going to spit out. And this actually goes to another point that was made just a couple of days ago, that developers oftentimes prefer working on the PC, although they don't state that out loud, but a couple of programmers from Ubisoft actually said this. I have a feeling they're getting in trouble because these are the same guys that stated that they're actually pressured a lot of the time for parity for different consoles. And they're actually saying that Microsoft are trying to push for 30 FPS on the PC, so it's not obvious that the PC is better in terms of the version, which is kind of rubbish and obvious to everyone else, but whatever. So anyway, Ubisoft actually state that what their sometimes strategy is to simply write 10 iterations of whatever version of feature you're trying to run, and then see which one works best, and basically hope that you get one version out of those 10 that's going to be usable. Because obviously if you get like one that's going to negatively impact the frame rates a lot, and then you get another one that doesn't quite do the job, and then you got and so on and so forth, and you find none of the 10 work. Well, that's just your SOL. You've got to redo the whole thing, and it really comes down to the compiler. Now, this is not news in terms of, we kind of knew this anyway, because of the out-order nature of the processors. It's very hard to actually optimize the compiler in that respect, because you sometimes just don't know what's going to happen, as well as some of the random nature of code as well. And so that's just kind of how it is, especially when you're dealing with compute and physics simulations and that type of thing. Particles, cloth, water. It's kind of random at times, and so it can be a little bit hard to actually do that. Finally, we're going to go into probably the meat, and I have a feeling that many people are going to want to know this most, but I've left it to last because it's not 100% news. It's something we kind of knew anyway. They had a final bar graph, which actually shows, it reads, and I quote, "Bonus, final performance, next gen can be sexy after all." And with this, it gives the relative performance of all of the systems, their CPU and their GPU. Very interestingly, though, they don't actually have the PS3 and the Xbox 360's relative GPU performance. I'm guessing it's because they're not really utilising compute. It's a bit of a shame. I wish they have somehow managed to squeeze those in, but anyway, it doesn't matter. So the relative performance of the Xbox 360 CPU is 34. These numbers we've already been over, but I'll just reiterate them. PS3 105, PS4 CPU 98, 113 for the Xbox One. This is all in this image is actually in there. I can't put these in simply because of copyright reasons. I don't want to get smacked. Ubisoft don't usually mind gameplay, but I have a feeling because of the subject matter they might get a bit upset with the inclusion of these. And PS4's GPU is 1600 dead on, which is an odd number, but whatever. And the Xbox One's GPU is 830, which is really surprising when you consider, well, there's not that much difference in compute shader between them. Yes, of course there's about 50%, but that still doesn't make quite sense. I'm going to guess some of the reason is because of other reasons, such as just the bus structure, maybe volatile bits having something to do with it. Unfortunately, they don't go sometimes into platform specifics, and I really wish they'd have gone more into the Xbox One side of things. They really focused on the PS4. Now, I don't know the reason behind that. There's a couple of theories, of course. One, because they just didn't really want to split themselves too thin. Two, they didn't want to talk about the Xbox One because of considerations, let's say. Or simply because they have more experience, or it's just easier to discuss one, or whatever the reason. But anyway, that's the numbers we've got. And so there we have it. So what's my takeaway on this? Well, the fact of the matter is, this leaves us with 3 questions. If you're looking at this video from a parity standpoint, 3 potential options. The first, the reason we're getting parity, is because of a PR reason. So in other words, Microsoft or another studio are putting pressure on them so that people don't get pissed because the Xbox One version is running at a lower resolution. That's one theory. Another theory is that the CPU on all of these machines, the PlayStation 4 and Xbox One, is just not powerful enough relative to the performance to issue all of these dispatches, and therefore that's what's causing the problem. That's actually a relatively good theory. Because if you're looking at the amount of dudes and dudettes that are walking around in like AC Unity in the background, you can start seeing there's a hell of a lot of them, and each of them are moving around, each of them have clothing, each of them basically have to make sure that that clothing looks realistic. It wouldn't look good if they were just walking around with like wood, like they're wearing wooden clothing. And it's not just clothing that has to be calculated. That's incredibly important. You've got to remember things such as artificial intelligence. You've got water effects, if any of those are happening, any combat mechanics, blah 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 blah. All of this has to be run. Plus, of course, basics like gravity and the game engine as a whole, and so on and so forth. So it's possible. Another theory, of course, is that it could be something to do with the additional 8 processors inside the PlayStation 4. Hell, for at this point, it could be a dozen different things. But there you have it. Hopefully, you found the video somewhat interesting. Now, Ubisoft do close this off by stating that the PS4 in 2 ms of GPU time ran 640 dancers, but there wasn't any form of metric for the Xbox One. So they don't really know what type of benchmarking they used here. Exactly what else was running, for example, and so on and so on. As far as I understand it anyway, they don't seem to be highlighting that information, which is a bit of a shame. Anyway, hopefully you've enjoyed the video. As I said, it's an article if you need more information, which would be pretty helpful if you want to check out. But with that said, I'm going to give my throat a rest before it goes on fire from the burning of the sore throat and cold that I've got. And I'll see you soon. Take care and bye for now.